Right, this is the final video of the HP 8112A pulse generator. Uh, Initially the error message we were getting on startup was E41, which is quite a common message and quite a common error on these pulse generators. And if you look at the all the channels and all the forums on the internet, that you'll find that most people say it's all doom and gloom. Its output stage is blown up, hybrids blown up. Yeah, maybe there is on some of them, but not in the case of this particular unit, and I'm sure on a lot of other units. What I did was I went through and did the calibration, and the calibration has fixed the problem totally. This unit, to me, looks like it's never been calibrated since it left the Hewlett Packard factory back in the 80s. It was quite a way out on its pulse width and its period times. So I've run through the calibration, and it's fairly straightforward. The manuals are available online. I mean, this is the complete manual printed out, double-sided. It's a big manual, but you only need, I think it's about 30 pages for the actual calibration procedure. So it's not, that's not all calibration, and it works great. It's exactly how I remember these. They're really nice and easy to use. Just up and down toggles for everything. Fairly straightforward. Various triggering modes. You've got an E-burst. I'm not entirely sure what this E-burst thing does, but you've got all sorts of various ranges. You've got a manual triggering, so you can fire off the setting when you want. That's easy enough to use. What else we got? We got this is our period and burst times. We got delay and double pulse. And it's good because it shows you if you've got an overlapping signal, like your period is shorter than your duty cycle, things like it will flag that up. Which is nice. This is our duty cycle or our width. So basically these things do the same thing at the same time, and that's quite nice to be easy to be able to understand. So width and duty cycle. That's our leading edge of our rise time. That's our trailing edge of our rise time. That's our high level, and that's our low level. Now high level is the voltage above 0 volts, and the low level is the voltage below 0 volts. So that's fairly straightforward. We've also got here, we've got this is sort of basically it's standard modes, which no adjustments for a trailing edge or leading edge. It's the fastest pulse it can produce. This is a variable pulse width version where you can actually adjust the pulse width, so you can adjust the pulse width, the rise time. That's the rise time. That's the rise time. That's the full time. So you can adjust that on the. Let's look on the scope actually. I can show you that. And this is a how do you pronounce it? It basically allows you to adjust sort of more to a sinusoidal waveform, so it just basically rounds everything up. A bit of a problem with the HP scope. I think one of the buttons is sticking. Okay, so that's working now. So let's have a look at the output. So there's our square wave there, and if we adjust our trailing edge here, so we'll increase the trailing edge, and you can see here as it's increase the trailing edge, starts to sort of slope off. So it's working really nicely actually. You can see here if you get a problem where you're exceeding the limit of the trailing edge to leading edge sort of differential, it will actually flag up a warning, things like that. So that's basically our square wave, where the trailing edge and leading edges aren't adjustable because it's trying to give you the best pulse possible, and that's our square wave there. And we're getting a very fast rise time. Scopes down to, so that's what's that? It's saying 10 nanoseconds. I mean, you've got to bear in mind the length of the lead and the coupling of the scope and things like that. So we've got memory storage here, which is this battery looks like it's been replaced recently, so that seems to work fine. A complementary basically swaps the positive to negative round, so it basically flips it over. That's no problem. Not sure what the limit does. Need to read all that up and also the set. I'm not so sure what that does, but at the moment I'm not that bothered. All I know is it works, and I know that I checked it this morning when I came in the workshop this morning. Usually if you powered it up after it's been off for an hour, it came up with E41, and it doesn't do that anymore. Now that, for people who've got this, and I'm going to sort of highlight and tag E41 in the comments, in the description, because E41 is quite a common error with these type of function generators. E41 was caused by basically one calibration error in the unit, and I'll point this out to you. What it does is this unit has a capability of going to a high level output, and this is high LC here. And if you go to high L now, it will just say limit or high limit. So this is producing its maximum output. But that requires a calibration to be correct in the calibration procedure. And let me just see if I can show you where that is. I've gone past it actually. It's towards the end. And it's actually, funny enough, I flicked through the calibration previously and I thought, well, it all looks okay. No, there's no problem there. So I thought, well, it's obviously a hardware fault. Here we go. High C. It's basically quite simple. All you do is you set these settings up here, and then you look for zero output on the scope. And you adjust a pot, which is so you want to adjust A1R506. So if you want to, I'll hold this still, and if anyone who's got this problem, they can photograph it. You adjust these levels, and you adjust this pot for zero output. But I was getting about 100 millivolts. I've adjusted that down. Ever since I've done that, this has cleared the problem. And E41 suggests there's a problem with the output amplifier as asymmetrical, or there's like a DC offset, and this is a DC offset adjustment for the high level drive. So that's fixed that, and as I say, it works really well. Very flexible pulse width generator. It's quite compact, even though it's very long. It's much longer than the look at the 4261 LCR. It's probably about another 6 inches longer than that. It's pretty hard to tell here, but it's certainly working okay. The battery is in good condition. That's a rechargeable lithium, so that's working fine. Check the power supply. First thing you do before you do anything is they tell you to check the power supply. The power supply ripple noise is sort of well within spec, and the voltages were absolutely spot on. So that's a testament to the quality of the HP stuff. It's got our line selectors on the side here, and we've got some various EPROMs here on the top board. The lovely thing is about these boards, they come out, and if you see this slot here, you remove these 1, 2, 3, 4 screws. That board will slot up and stand vertically there, and the board below it, there's an aluminium plate, screen plate, that stands vertically here, and you've got access to everything. Really nicely thought out piece of kit actually. GPIB control on the back. As you can hear, it's got a fan that runs mainly because it's quite a high power output unit. It'd be nice if it was a thermostatically controlled fan, but it's not. That's no big deal. It looks like the GPIB's connectors never come off. It's absolutely pristine, so obviously never been controlled under GPIB. I doubt if I ever will use it for GPIB as well. So for something I picked up with sort of like a tenth of the price they usually are on eBay in working order, it's worth bearing in mind that if these error messages aren't always a catastrophic hardware failure. I mean, yeah, they can be, but in this particular case, I was lucky. It was a calibration that needed to be run, and I got a nice, fully functioning pulse generator from HP. Thanks for watching.